How's it going, everyone? Welcome to this week's um, Code in Cask. We've got some cool stuff going on. I've been working on putting together a IronPython kind of field manual for an upcoming blog post that's going to be coming out shortly. And so I thought this week we'd be going over, we kind of go through that as a video and kind of on the stream and talk about some of my favorite parts of IronPython. It also times well because one of our buddies, Kevin, just published an article on Python malware for Windows, so it's not the same thing because Python and IronPython have overlap, but they are different TTPs, which we'll talk about. But it is a cool place to start. So let's go ahead and grab that in there from Trusted Sec. Yeah. So, like I said, one of our buddies, Kevin Clark, posted this last week. It's an introduction to Python malware, which is really cool. There's been an uptick in Python malware in general. One of the things that he talks about is how they've moved off of doing. Oh, I'm sorry. Give me 30 seconds, guys. I forgot to share my screen for you. I do that more than I should, so I apologize. Let me just close out a few things. Okay. Helps to share my screen. Cool. So, getting back to this, sorry about that. Python is now included in the Microsoft Store. So one of the reasons that Python malware hasn't played a large role in traditional Windows TTPs and game plans is because Python's not installed by default on a lot of Windows computers. That's starting to change a little bit. Kevin talks about that some in his article about how you can actually, it's not uncommon nowadays to find Python installed in computers or in environments. I just did a pen test a month or so ago where I was on it, and it turned out that not only was Python installed in their environment, Python had been given an exclusion from all of their antivirus, so you could drop like whatever you wanted into the Python folder. Because I'm guessing the interpreter, since it wasn't like Microsoft signed, kept getting flags, so they just like whitelisted the whole folder for all their Python projects. So you could actually leverage that to drop in like any projects that you wanted to use and not worry about like the AV killing it when it got dropped in. So Python is becoming more common on Windows machines, just not only in the environments, but like you can now get like Python integrated into Excel through Jupyter notebooks, that kind of stuff. And so there's been like a lot of interesting things going on with that. But so you can download, if you want to go traditional Python, you can download it and just kind of use it directly from the store. Alternatively, this is something you've been able to do for a while, but again, since it's starting to become more common in environments, it doesn't necessarily flag when you drop the binary. You can just download the Python interpreter and drop the whole, like create a zip file and drop the whole interpreter yourself, and then just install it that way. And if you download it from, he mentions it in here, if you download it, the Python file from the Microsoft Store on another computer and then transfer it in, you still get like all of the signed things from the Microsoft Store. So we open the application, we download it, and then paste it over. Yeah, so like you said here, the installer packages are digitally signed. So that's how things are working um, in this third party. So the installers are safe to use by using like another thing. If you can't you directly use the Microsoft Store that allows us to install it. So very cool. um, but so Python stuff's growing. There's been a move away from PowerShell that's been going on for a while. But I was looking up stuff. PowerShell's still used. Lots of people. It's still like the top MITRE TTP is using like CMD or PowerShell to kick off stuff because it's still the easiest way, and lots of people whitelist it. But what we've been doing is actually moving on from that and going to IronPython. There's a couple of reasons to do this. If you've taken any of you've watched any of our IronPython streams before, or taken like any of our workshops or anything like that, you've probably heard us talk about the bring your own interpreter concept before from Marcelo, which allows us to do all kinds of cool things because it turns out that in .NET you can create what are called dynamic languages, which are scripting languages, and the engines for dynamic languages are .NET assemblies in and of themselves, so we can bring them in without having to install anything. So if you've never heard of uh, either of those things, I will drop the link in for everyone. And then I will also drop in the link. We have a very basic workshop that we taught at Black Hat, or not Black Hat, at DEF CON 2 years ago. And that we updated last year. And so we'll go ahead and drop it off for you guys. So you can go look at some of this stuff here that we'll be going through. But there's lots of cool things that we can do in IronPython. So like I said, we're going to be releasing kind of an offensive. I've been working on this blog post. It's very long, as you can see. It's going to be called like the Offensive Operator's Guide to IronPython. And we're going to go over stuff. So that's what I'm looking for. And I'm actually going to take this opportunity to also pour myself some whiskey. This week I decided to go a little old school. We're drinking a Bell Mead from 2020. They don't make this anymore, so it's kind of a cool bottle. It's before now. If you're not familiar, well, most of you probably aren't. So Bell Mead used to be a whiskey brand. It's still sort of sold. Like a lot of stores still carry it because there's like lots of old stock of it. Not this one anymore, but of just Bell Mead stuff in general. It was made by a company that's now called Green River. So if you go in, you see stuff that says Green River Nelson in a liquor store. That's that's who used to make Bell Mead. The difference is Bell Mead, they bought it from a place called MGP and they were repackaging it and selling it. Green River is their own distillate. The Green River stuff's not as good as the Bell Mead stuff, so you won't see it bought as much by like collectors, but it is interesting. But anyway, so looking at the DOR, you have this stuff that's like VB, C++, C#, JavaScript. These are all top of the common language runtime. IronPython uses a different base compilation library, which allows us to do some very cool things. So rather than going through like the C# compiler or our PowerShell engine, we're going through our own IronPython compiler. It's not really an IronPython compiler because the way the DLR works is everything gets converted into trees and they're compiled by lambdas, and the lambda that's the class is responsible for compiling lambdas within the common language runtime is different than what is used to compile C# code. C# code doesn't get converted into these lambdas. It uses a totally different compiler. So that allows us to avoid a lot of the hooks within stuff. But it also gets us kind of to like our first demo. So IronPython's got some really cool stuff. Let me bring up Notepad++ to show you. And just so everyone knows, this week we're only going to be going for about an hour. We're trying a new format to see, like, kind of, I think we're going to try and do more frequent, but shorter streams rather than kind of like every other week, like one long, like 2-3 hour stream. Just because we've gotten busy with all the stuff we're working on. And so um, that has made it more difficult for us to get to things. So we're going to go new file, save this. And I like using Notepad++ when I'm doing development stuff for things. So go ahead and do this. So I'm just going to save it as Python. This will be fine. Okay. So the first thing we're going to talk about is how IronPython has access to the DLR, or not the DLR, sorry, the Win32 APIs. So one of the core things that we need to be able to do for accessing the Windows APIs or doing modern tradecraft is to access the Win32 APIs. These are all the functions that are in like your kernel32.dll or your ntsd.dll, those kinds of things that are we'll talk about it at the end because we're going to go like all the way through to like doing like callbacks and some of the syscall stuff that you would try to do in traditional TTPs. You can run it all in IronPython. But the first thing we have to do is be able to access the Win32 APIs. So in this one, we're gonna use get proc address and get module handle, which are very standard in our kernel 32. In our kernel 32 library, like kernel32.dll, we can, or kernel.32.dll. These are where all of our function calls exist, or Win32 APIs. If we bring the whole standard library with us in IronPython, we can directly we can use C types to just call these directly, which makes things a lot easier. We're going to go over how you would do this without using C types or like the standard library after this. But you can see this is pretty clean. If you're familiar with AMSI bypasses, will probably look pretty familiar. This is the very standard, just AMSI scan buffer patch bypass that's been around forever now. One of the things that you have to note is these kind of system.uint32s where we're casting things to .NET data types. The biggest trip up in IronPython TTPs is your data management, or data types management. If you don't manually cast types, whether that's into the system.uint32, which we're using here, or in our get proc address, these are C types. If you see like this C underscore, that means in Python or IronPython, that means data type that's been defined in C types. So we have to cast everything to those. If you don't do that, IronPython will automatically treat them as Python types, and you are not guaranteed the type when it gets passed in. Not only is it because like Python is like a dynamically typed language, so technically your variable could be a string or it could be a number depending on what it was used for last. But the actual like integer types are different across these things, and like Python doesn't distinguish between a lot of those, and so it's not guaranteed that when it passes it in, it'll pass it in the same format every time. So it makes your code, if it works at all, it makes your code very unstable. So I'm going to go ahead and just pull up an IronPython interpreter. So I have IronPython installed in here, so I can just run it with IPY. So just standard iron. Let's see, come on. So just standard like IronPython, or not IronPython, standard Python like data imports. It's pretty straightforward. So the first thing we're going to do is just import all our types here. And then the next thing we do is we're going to use load library. So because we imported everything from C types to C types import, we have access to like all the WinDLL, or all of the predefined functions under WinDLL. So there's like just straight up load library. So it'll automatically fill that out for us. If you do like the kernel 32, and then we do a dot, like there's a whole bunch of different functions. If I can get to them. Well, all these private variables. Oh, whatever. Yeah, it doesn't want to. Oh, I deleted 13. So like you can get like get last. Oh, because I haven't imported. Or no, that should be working. I don't know why the autocomplete's not working for me. But we'll just cut it, copy and paste it in. So we get a handle for the AMZ DLL, which is nice. Oh, this might be. Oh, I am missing a line here. We just got in there. This should be handle. Okay. So now we have our handle. We have to define what our return types are for these. This gets into that typecasting I was talking about. Oh no, we defined handle down here. Never mind. Didn't need to do that. I lied. So we are going to first define like our arguments and our return types. So again, if we don't define these, then we don't necessarily get reliable behavior coming in and out of the Win32 API function because of the way IronPython controls its variables. So now that we've done that, we can grab our handle. Our handle now has a value. And so this is like where it can kind of get funky. So in this particular script, it'll work, but if we do like, you can see that it's just an integer in IronPython rather than an actual pointer, even though we told it to be a pointer here, to return a pointer. So it was returned as a pointer, but because we just put it into, we just gave Python a handle, like variable to put in and didn't cast it to anything specific, handle automatically gets converted to an integer, even though it was passed like a pointer, because the pointer is just like a value of where to go. And so this can cause problems later on in more complicated scripts that we'll look at. So now we're going to go ahead and do like our get proc address, which again will define the types going in and out. This helps tell Python as well how to, or IronPython, how to convert these when in the background when we're going to pass the data types in. So C, because we're defining these argument types and the return types, C types handles the conversion in the background for us. If we didn't do this, which I'll show you guys afterwards, then it wouldn't work. We would get like errors if we don't define the types first, or at least we should theoretically. So once we do that, we have buffer address, and then this is where we are recasting buffer address, because we could just because Python does not allow you to define the type that it'll be. But if you do use something from the .NET or the C types, you can cast it. So we're telling it to cast this int pointer. We're telling it to cast it as a .NET int pointer, integer pointer. And so if we do like our type on buffer address, you'll see it's an int. But after we do this, if we run our type again, you see that it's now a class int pointer, which makes it so that we can actually pass it into our next function call and that it'll work properly. We could have overcome this a little bit by instead of, this is to show like the two different ways to manage things. Instead of defining the argument types here in a separate line of code, we can just cast it into the correct types that virtual protect expects, and then just pass them in directly, because we don't have to tell C types how to do that conversion since we are casting them ourselves. There's pros and cons to this in terms of like code management, but it's really going to be up to personal preference for how you want to do that part of it. I just recommend like picking a way and staying with it. That didn't work. Yeah, I'm just going to redefine buffer address because it didn't like that we cast it twice in a row. Okay. So now we're going to do our virtual protect, which is turns the memory space, since it's within our process, to allow read write. And then we do our patch, and then we marshal the patch. So now we don't really get in like we do some PowerShell. You will get like a statement that says like true after running that patch or that marshal.copy. We don't get anything in IronPython, but if we ran a PowerShell script now from within IronPython, which we'll do in our next step, you'd see that AMSI has been bypassed, and we can now run whatever script that we want. So let's test something real quick. So normally I use the word AMSI context as a way to alert, but last week when I was working on this blog post, it was no longer being flagged. Yeah. So Microsoft has changed something within the way Defender works. I haven't had time to go dig into it, but like a lot of the things that used to cause Defender to go off no longer apply, and I'm not sure. They have broken these detections by accident in the past, but they also rolled out a whole bunch of behavioral detection stuff last year, or like in November, like about, what is that, 4 months ago now. And so this may just be a toning down of like the contextual identification, like the AMSI scan detections, since they can rely on those behavioral detections now. But I haven't had a chance to dig into this. Just kind of an interesting note, because I'll show you, like if we tried to cut and paste the standard Empire launcher, we will still get a detection. 1 second, let me grab one for that, just to show you guys. So if we try to run this, you'll see we still get the contains malicious content, but it used to be like we had to we had to break up like the system.management.amc utils. Like this used to flag like just this sentence or just this line by itself, but it no longer does. So I don't really know what's going on because it's theoretically a weaker detection now. Because if I go like this, we still get that. Now if I go back up here, right, we get the instead of it being flagged as malicious, we just got this no. So the AMSI bypass works, but their detections have gotten much less aggressive. Kind of a tangent, but just kind of an interesting to note type of thing. But just real quick to show again about how like if you don't define these right here on a function, that it won't work properly. So we're gonna do this Windows load library. Oh, whoops, I gotta run more imports first. So we got our handle there. Now this one might work just because all we're passing in is a string, but it is a wide character pointer instead of a string. So if we pass it in, let's see if handle. Yeah, so see, we got like a invalid handle now, or that should be invalid. Whereas if we go define our stuff, we get an actually valid handle. And that's because of the way the typing works. Because we didn't define the typing going into the argument, we get this weird issue with our handle because it's not valid. Because it's passing in a string and then it converts it inappropriately instead of a string pointer. So just kind of a like again foot stomp to make sure that you're doing your data type management correctly. Let's see, have we got any questions? Nope, no questions yet. Okay. So the next thing that we're going to go over is accessing other DLLs from within our IronPython. So the next thing is the next thing is going to be to show you guys an example of how to do this without the standard library. It is much longer. So this is what our code looks like if you don't want to use the full IronPython standard library. It's quite a bit longer and a little more confusing to use because we have to go define each of our types or each of our methodology ourselves. This is how like kind of looks if you're familiar with pinvoke and C#. This is kind of what it looks like. And so we can do the same things. We can import all of the .NET types because .NET is inherently accessible from within IronPython. So even though we aren't using the full standard library, we don't have to. One of the things that to note though is even though you don't have to use the full standard library, there is one file that you do have to use from the IronPython library. There's a Python file that is not not included in the Python standard library, but the IronPython standard library, which is the CLR type class. If you don't include this, which 1 second, I will give you guys a link to look at this as well. Oh, they moved it again. So it is normally here. I was going to link you guys to it because it's asked in this question, because I asked a while ago where it is, because it's supposed to be from the Git and it's supposed to be CLR type.py, but it is no longer there. So let's see if we can find where they moved it to. Hold on. Okay, it was there. I don't know why we got that error. Weird. So you need this file, the contents of this file. It's not super long. It's a little long. And you technically don't need all of it, but you need the CLR types class that's in here. That's defined. Like, so this class. So we need all of this part that's included here, but and some of this other. You need this file. If you don't have this file included, then nothing will work, even without the CLR types or without the standard library. But besides this one file, you can do everything without the standard library using this pinvoke methodology. So it looks a little funky, but it's not too hard. This meta class thing is like an issue, so you have to define the meta class as the CLR type.clr class, and then everything will work from there. So I'll just show you guys real quick. Not going to be all that interesting because it's just going to look the same. And if you exit the interpreter and restart, it'll reset and like start a new process under the hood. So you could reset like your MVDOL code and everything. So when cutting and pasting in, it's helpful to just remove all the spaces if you don't need them. It just helps with the interpreters need to be able to interpret this stuff. So cool. So we'll import this stuff first. And then the other change from that is I mentioned before, like when we were looking at it, that we had to define a pointer to a string and not just pass in the string itself. So we actually have to manually create, because of the way things get passed in, we have to manually create a pointer to the string using Marshall rather than being able to just pass the string directly like we did previously. So this is the only other step that we have to do. And then we can run it. Oh, that's new. That is very new. Let's see what our protection history says. So I'm sorry, I don't know. Okay, so it detected a AMSI patch when we did that. That's interesting. It did not do that last week when we checked that. But it didn't detect our previous AMSI, our other AMSI bypass. When in IronPython, when we use C types, it wasn't detected. That's interesting. So there might be a new hook in our in one of our calls when we go through when we do a p invoke rather than in it through C types. That very interesting. Does anyone have any preference on if I keep going through our TTPs or we do a little bit of investigation on the fly just to see? Well, we need to test everything. I need to show you the next part of the TTPs anyway. So the next thing that we need to be able to do, like if you like run seatbelt or any of those kinds of, not really seatbelt anymore because it gets detected, but if you want to run any project that uses C#, we need to be able to add references to our code. So this is just like a very quick and dirty, like how you import COR references. So because this is in the system.management.automation is in the global list for the DLLs, we don't have to give it the location of the file, but you can give it a reference to a .NET assembly to add in using this COR.add reference, and that will work. But so this is how you'd run a PowerShell script in our IronPython. Yep. So all we did was we added the reference, this COR.add reference. Then we were able to import stuff. If let me exit real quick to show you guys. If we try to import from that system.management without running that add reference first, you'll get no module named management. So this is how we can add in references. If you ever get an issue like this, you can just go ahead and try using this CLR.add reference, and then you should be able to access whichever assembly you want, assuming that the assembly is public. If it's not public, then you'll have to go through some other reflections shenanigans to be able to get access to it. But real quick for fun, since we just saw that, let's try adding in a string that we. Okay, yeah, we'll do the investigation now then. So let me grab that AMZ bypass, or that string again, that we were able to get stuff wrong. So. So when we go to run this, we should get an error. Oh, let me close the run space for, oh, we already closed out. Okay. Yeah, so we didn't even get to collect the output. You can see that when we went to run, when we invoked the pipeline, even from within IronPython, we get the message that stuff was blocked by our by AMZ. This is the standard AMZ's like owned your shit thing. Yeah, and output has nothing because it got blocked. So so we know that AMZ is working from in here. So now if we go run the first bypass that we had in here, that didn't get flagged. Let's try that first real quick. Actually, we should just be able to. Okay, so we didn't get flagged, and now if we run our pipeline invoke, oh, we're gonna have to oh, hold on. Let me clean house real quick and just close the run space first. So we didn't get that error that time. So There's going to be no output because we didn't actually output anything, but we see that when we ran the command to invoke, we didn't get flagged, and we didn't get whacked like we did when we tried to do the p invoke. So let's go see if we can figure out which step of that actually. So first, let's do 2 comparisons real quick. Let's see if there's anything, because these are old examples I've had saved in my notes for a while. And I didn't compare them to see. Let's see if the patch numbers or values are different. Okay, so this one's the one that got us caught. So, and these numbers right here are patch numbers that we care about. These are what usually get flagged by AV or EDR if you get, or these byte codes right here, if you do get hit. So OX57, X07, X80C30. Wait, did that say C30 instead of C3? Oh no, C3. Okay, so those are the same. The other thing that could be different is our protection flag. But I think, yeah, those are the same. So these are all being, it looks like, except for the fact that we're p-invoking, these are all being done the same. So let's see if it's a specific step or if it's just specifically when we go to patch. So since it's already been patched, I'm just going to try rerunning our patch without the, through the p-invoke method and see if we're just behaviorally getting flagged or if there's something going through some kind of filtering. It shouldn't be possible for this to be going through some kind of CLR hook because you can't inherently hook the DOR unless they change something very significantly under the hood and just didn't publish it. Because like you used to not even be able to attach you're not supposed to even be able to attach WinDebug to the DOR. So let's just go down to this far. Okay, so we didn't get flagged there. I haven't gotten flagged yet. So we didn't get flagged this time. Okay. So now let's just try running this directly instead of through AMSI. Okay. Didn't get flagged. Huh. Why did we get flagged last time? Okay, maybe we just happened to have been being scanned like right at that moment. So let's try just doing it one big block like we did last time. Yeah, so when we do it all at once, we get flagged. Okay. Huh. Where's this? Anyone remember the command for dumping your the detection? Like, what was your last detection? I have it in slides somewhere. Because I want to see it. So hold on, I'm trying to. I have the command right here. Okay. So this is something that's actually pretty useful. If you've never seen this before, even without admin privileges, um, like if you try to go click on like this like protection history, you have to confirm that you're an admin. Without that, you can actually still, unless they change the logs for certain things, you can actually find out the way it was detected by dumping it this way without needing to be an admin. Oh, oops. And I'll drop this command in for you guys in a second. Okay. No, that's 116. We should have gotten. Oh, whoops! I missed a one. There we go. Okay. So, oh, yes. So there's something new in here that's detecting it. Oh, it says that AMSI's detecting it. Oh wait, no, that was probably when I ran the IronPython stuff, or not the IronPython, the PowerShell script that we knew was malicious. Yeah, so detection type concrete, but detection. So this is some one of the behavioral things that they just added. But it's weird that if you take long enough between your commands that it doesn't catch it. So let's try running this one, which wasn't caught as like in like all at once to see if there's something there. But here's the command for everyone. Anyone needs it. So let's go back into our IPY. Okay, so we're just gonna try running this as one big block. Let's see if we get flagged. Let me try entering it. Next return line in here. Okay, yeah, so if you do it all at once with that extra line, like if you do it too fast, it gets flagged. That's really interesting. Because there's all kinds of stuff we can do from an automation standpoint to add in like a second of like, so let me see if I remember the Python command for pausing. Can you just do straight sleep 0 or sleep 1? What's the Python command to totally blanking? Oh, it is sleep. I just forgot to import time. Oh, time.sleep. There we go. Okay. Okay, so let's see. Let's see if this keeps if we just add in a simple sleep timer in it, if that keeps us from triggering it. It does. That's fun. That's really interesting. Oh God, what happened? Oh, helps if I include all the imports. Yeah, so I commented out the sleep and we automatically get flagged. So all you need is a slight pause in your code execution and it'll no longer flag you as malicious. But that's really interesting. So so they're doing some kind of behavioral detection. But I don't know exactly why a simple pause like that would cause behavioral detection to uh, fail. Probably because it might be some kind of machine learning thing, and since code doesn't get executed like that when it's a payload um, versus something else, it doesn't have training to know that like a pause doesn't necessarily mean that it's not malicious anymore. That's my guess, but that is really interesting. Very, very interesting. But we only have like 5 more minutes left um, in our in the stream. So does anyone have any questions? Oh, oops. Well, we know that's gonna work. Yep, that's very cool. Yeah, of course. Thanks everyone for coming. I'll be playing around a little bit. I wonder how short we can go. I think sleep has to be whole seconds. Let's see. Let's see if we just throw a random command in if it'll work. Like we just do it. Whoops. Like if we just make this an a equals 5 plus 10. Ah, dang it. Gotta make sure we get that extra line so that it auto executes. Otherwise, we know it won't have an issue. Okay, yeah. So see, so you need some kind of sleep. Just like a millisecond pause is not long enough. That's so interesting. Yeah, I'll have to make some kind of social media post about this because this is an interesting thing to find. Like really, really interesting. Um, So let's see. Can sleep be done in milliseconds? Python stop for 5 milliseconds. Okay, so yeah, so we can do fractions of a second in sleep. So let's try that real quick as our last thing. See if we can identify for exactly how long it needs to be before it gets flagged. Oh yeah, even just that was enough. Yeah, so you just need some amount of meaningful pause in the execution, and it executes. Here, let's see now that we've disabled AMZ if we run it without the. What just happened? Okay, so. Huh. Well, that and. That implies that some kind of AMZ analysis is being done, but AMZ shouldn't be being done on this. And if it was an AMZ detection, a sleep wouldn't break it. If like the A equals 5 plus 1 or whatever should have broken it if a sleep does it. If it's just AMZ, because all AMZ does is scan the text that's entering. So, huh. This gets more and more curious. Okay, so this is like basically non-existent. Stop. Oh, whoops. Not what I meant to do. Yeah, okay, so that's definitely not AMSI then, because if it was AMSI that was causing this to break, I'm a little more confused now, because if it was AMSI and we were just bypassing it, this value shouldn't actually matter how much was in here. And in fact, it being longer would make it more likely to bypass AMSI. But once we patch AMSI, it looks like this behavioral detection is no longer relevant. So I'm very intrigued by what is going on here. But that's all we're doing for today. So I will see you guys probably next week. And thanks for coming along, and we'll see you all next week. Bye. Yeah, definitely an interesting find.